Okay, we just have, well, wait, today's Tuesday. Oh, I had the wrong day. I thought today was Wednesday for some reason. Anyway, we need to finish up chapter 15. And what we're really going to look at is titrations. And hopefully, this is all just a review of chapter 9, because we finished chapter 9 by doing titrations since they're related to our normal molecular weight questions that we were dealing with in that chapter. And we just said that molarity is just one more set of units to sort of learn and master. And so we actually covered what we're talking about today already. But I figure let's do it in chapter 15 because it's first off in chapter 15. And second of all, it'll be either on the chapter 9 test for the final or in the chapter 15 test for the final, one or the other. I don't remember which one I put the questions in, to be honest. So, a little bit of review. What do we mean by molarity? Moles of what? Yep. Well, moles of X over liters of solution. And we really tend to think about this as essentially the liquid equivalent of what? So molecular weight, meaning molecular weight has units of grams per mole. So one of them is based on volume measurements. One of them is based on mass measurements, but they're used for the same thing, meaning that we almost always need a mole-to-mole ratio when doing chemical reactions and doing chemical calculations. And so molecular weight and molarity are the part that gets us from either grams or milliliters to our mole-to-mole ratio. And then it also tends to get us to our answer. If we remember from chapter 9, most problems fit into the following category. So if I have a reaction that A goes to B, then all of my calculations center around converting from moles of A to moles of B. And for that, remember, I used my mole-to-mole ratio from my balanced chemical reaction. And then the idea was that there's a bunch of different ways to get to moles. And so we could start with grams, in which case we use molecular weight. In this section, we're using milliliters, which means we're going to use molarity as our conversion factor. And we could, even if we really wanted to, start from atoms and use Avogadro's number. Oops, times 10 to the 23rd. Got an extra set of numbers. And then the idea is that at the end, we have the exact same process, meaning we can either go to grams, we can go to milliliters, we can go to atoms. And again, it's just the reverse: molecular weight, molarity, and Avogadro's number. So when in doubt, anytime we have a question that talks about information about A and asks us for some information about B, we know that we want to have a mole-to-mole ratio in there. And then specifically we use molarity when we're talking about titrations. Do you guys remember what a titration was? Yeah, so we did an entire lab on it. The idea is that we take a known substance and titrate, which is just a fancy way of saying react it with an unknown substance until the concentrations are equal, at which point, well, we call that also the equivalence point. So the concentrations are equal, we call that the equivalence point. And if we're specifically dealing with acids and bases, a lot of times we call it that neutralization. And a neutralization simply implies that the pH is 7, meaning the reaction is neutral. I've taken all of the acid, I've reacted it with all the base, and I don't have any acid or base left over, so my pH is 7. And that's what we use an indicator to determine. Therefore, finding information about the unknown. So I'm hopefully doing kind of a big review. First off, we have the time to do it. Second off, this will help you hopefully with our Chapter 9 stuff. Did you have a question, Aaron?
What, the equal under the concentration?
So the equivalence point is another phrasing for it, or neutralization. I know, my handwriting's kind of piss poor. It's a little tiny too, probably. And then some more review. Our general strategy is that molarity is always a conversion factor. Therefore, never start with it. And we also said that if I have 1 unit in my answer, that 1 unit gets converted to 1 unit. And that if I have 2 units in my answer, then I need to kind of start off with 2 units. And what that really means is that if my answer is in, say, grams, then I need to start off with, say, grams or milliliters as a starting point. If my final answer wants to know the molarity, meaning moles per liter, then I have to start off with 2 pieces of information here, X and Y. So a lot of times we approach these problems backwards. We say, what units does the answer have? And that kind of tells us where to start. Another question on my handwriting or anything?
Conversion factor?
Yes. Because otherwise it's a big word. I feel like I should make a dictionary of J's abbreviations to hand out on the first day of class. Okay, so this is all sort of esoteric. Let's look at a couple problems and try to apply this to it. And again, this is good review for everything in Chapter 9. So if you want to go look at your Chapter 9 homework, the very last homework for that section, if you want to look at the Chapter 9 exam that you guys had, there was probably a titration problem or 2 on it. Figure that on this test there'll be a titration problem on it from that or something similar. What does that say?
It says that it's over 90. Yeah, she just exited out of it.
Oh. So you can just push the what button?
She pushed on a remote.
Oh. I got like 10 buttons. Enter. Yeah, that works. Nice. Okay, so let's say I have 100 milliliters. Oops, let me add some sig figs. God darn it. Let's do this. How many milliliters of 3.00 molar H2SO4 is required to neutralize 100.0 milliliters of 2.00 molar NaOH. So a lot of times where to start a problem like this is the hardest part. And then the other thing I want you guys to pay attention to is also the pattern that we're going to see. So if I take a look at my information, the question says how many milliliters? So I know that I need my answer to be milliliters of H2SO4. Now we already said that molarity is our conversion factor, so I'm just going to kind of temporarily cross those out. What's the only thing I can start with? Yeah, 100.0 milliliters of NaOH. So I want you to notice 2 things about that. First of all, a singular unit goes to a singular unit. The other thing to notice is that for all these problems, we're always talking about 2 different things. When I say that I'm converting A to B, what I'm saying in this problem is I'm converting sodium hydroxide to H2SO4. And so I know that if I'm going from talking about one compound, sodium hydroxide, to talking about another compound, sulfuric acid, what do I have to use? Yeah, mole to mole ratio. So at some point in here, I need to use that mole-to-mole ratio. Now, what do I need to have in order to use a mole-to-mole ratio? Yeah, I have to have a balanced equation. So at some point, I have to write the equation. So this is kind of a double question in that not only do you have to do the titration, but you may have to write and balance the chemical equation. So I've got sulfuric acid plus sodium hydroxide. What type of reaction is this? Yeah, it's an acid base, which is really just a special case of double displacement. So I know that I swap the sodium and the hydrogen, so I get NaSO4 plus HOH. Now notice I only swapped one copy, right? Meaning even though there's two hydrogens, I just wrote HOH instead of H2OH. And then after I do my swapping, and I guess I'll be complete, I'll put heat there. What do I have to do after I swap? Yep, I need to balance the charges. And so sodium is a +1, sulfate is a -2, +1, -1. So I need to have 2 sodium sulfates, and I need to have the water is already balanced. We should also remember that at some point we should check for diatomics. And here, what I'm doing is I'm reviewing kind of the steps for reactions, right? Things you're keeping in the back of your brain. Check for diatomics, check to see if you need heat. You, of course, need to balance the reaction, which means that I need to have 2 sodium hydroxides, and I need to make 2 waters. Diatomics mean things like hydrogen is never H, it's always H2 in a reaction. Or, you know, if it's in an aqueous solution, we can have an H+ ion when we're doing our ionized equations. But in general, hydrogen will be found as H2, right, in a complete reaction like this. And then, of course, we need our states. Now, do you need all of this in order to do this problem? No. Do you really need the states in this problem? No. Do you need to balance charges? Yeah, because if you don't balance the charges, you can't really balance the reaction properly, right? And to get to your mole-to-mole ratio. Okay, so I got my mole-to-mole ratio. So now I'm going to take my 100 milliliters of NaOH. And we know that we eventually need to get to moles. What's my conversion factor to get to moles? Molarity, right? And so, since molarity has units of moles per liter, and remember, we never use capital M in a problem, right? We always write moles per liter in the conversion. So I need to go and say that 1 milliliter is 0.001 liters. And then I can use my molecular weight, which says that I have 2.00 moles of NaOH per 1 liter. And so this whole part right here is kind of me using my molarity. And then, of course, we can use our mole-to-mole ratio. So I know that there is 2 moles of NaOH for 1 mole of H2SO4. Does everyone notice where that's coming from? I think you guys have pretty good recall here, it seems. Most people are remembering that. That's good. I'm kind of going through it nice and slow, though, hopefully. Filling in any gaps, hopefully massaging your memory until it pops back up. Let's see, 1 mole of then we use our molecular, or our molarity again. We know that I have 3.00 moles of H2SO4 in 1 liter. And then we want to convert from liters to milliliters because the question asks us for the answer in milliliters. We know that there is 1 milliliter is 0.001 liters. And if you plug this all into your calculator, you should get 33.0 milliliters of H2SO4. And because all of my starting units had 3 sig figs, my final units, or my final number should have 3 sig figs. The other thing, is it 33.3? You're right, it would be, because I can do the math in my head. I don't know why I have 0.0 in my notes. It's silly. One thing I want you guys to be aware of, there's 3 in the molarities, right? We said that so we said that conversion factors for like metric units and English units and things like that have an infinite number of sig figs, right? Molecular weight has whatever sig figs is in the periodic table. Molarity has whatever sig figs are in the thing. So at the beginning of the semester, we made that broad statement when we were just talking about metric units and just talking about US type units and going back and forth between them, that we'd assume they all have an infinite number of sig figs. But now that we know a little bit more chemistry, and we know that, like for instance, that 3.00 molar H2SO4 is something that we had to make up, meaning we mixed the solution in the lab, then we should go by whatever sig figs it has, meaning it's not really a 3.000000. Whereas, for instance, the definition of 1 inch equals 2.54 centimeters really is exact. It really means 1.000 to infinity inches is 2.540000 whatever centimeters. Okay, one thing I want to urge you guys to do, double check to make sure all of your units cancel out. It's very easy to write one of these things upside down and go, oh, of course I'm doing it right. And so double check your units. If they all cancel out, you probably did the problem right. If they don't cancel out and you accidentally flip something upside down, then you can catch it and go back and fix it. So this, I would say, is our standard titration problem. The other sort of variation on this problem is to do a problem where we're solving for molarity. So if I have 100.0 milliliters of 2.0 molar HCl neutralizes 50.0 milliliters of NaOH, what is the molarity of the NaOH? And so if we're thinking about it, what we're really doing is we're trying to get moles of NaOH all over milliliters. I'm sorry, liters, duh, of solution. And so since we have 2 units to finish with, I should have 2 units to start. And again, I don't want to start with my 2 molar HCl. So what I really have to choose is, should I put the 100 milliliters of HCl on top, or should I put the 50 milliliters of NaOH on top? Nope. You had a 50-50 chance, Jess.
Don't you have the, so, don't you do 100 milliliters over 50?
Yeah, the reason we can do it, we want to do it this way, is when we talk about solution here, that means solution of NaOH. So here we just have to convert milliliters to liters. And on the top part, eventually, again, we have to go to a mole-to-mole ratio before we can go to moles of NaOH. And so if you tried to start with your 50 milliliters of NaOH, the first thing you try to do is convert that to moles. But you can't convert milliliters of NaOH to moles without knowing the molarity of the NaOH, which is what the question is asking. So even if you started this problem wrong, what you should realize really quickly, and this is the wrong way, so write it down if you want, don't if you don't want to, is that you're stuck right here. You can't say liters to moles of NaOH because you don't know what it is. Now, you can try using molecular weight, but we don't want grams per mole because we're in milliliters, right? So if nothing else, by double checking your units, hopefully you would notice that, or if you made a mistake. Now what step am I skipping here that Jay just realized? Yeah, I need an equation, so I'll sketch it out down here. But it should be pretty obvious that HCl plus NaOH is just a 1-to-1 ratio that makes NaCl plus HOH. So it's just a 1-to-1 ratio. So I am going to take my advice, and convert milliliters to moles. So I've got 1 milliliter is 0.001 liters. And technically this is HCl, so I might want to keep track of that. And then I know that I have 2.0 moles of HCl in 1 liter. And so here's my molarity conversion. And then, you know, the pattern should be kind of familiar. Here's my mole-to-mole ratio. We know that 1 mole of HCl is 1 mole of NaOH. Oops, that's ugly looking. And what we should notice is that, you know, I've got my milliliters of HCl canceling, my liters of HCl, my moles of HCl. So here I'm sort of done, meaning I've already got my moles of NaOH. And so then what I'm going and doing is actually going way back to the beginning of the problem to make the next cancellation, which is simply to say that 1 milliliter of NaOH is equal to 0.001 liters of NaOH. And so that's canceling out at the very end, my milliliters of NaOH. I'm just left with moles of NaOH over liters of NaOH, or liters of solution. And how many sig figs should I have? Since my molarity has 2, I should end with 2, and so this works out to be 4.0 moles of NaOH per liter. Or if you wrote 4.0 molar NaOH, that's a perfectly acceptable answer also. So those are the 2 types of problems. Realize that you're either going to be starting with both values or the singular value, and it really should be pretty easy to tell which of those 2 values to start with. I'm going to throw one other question at you as sort of a trick question, because both of these topics are on the test, and I would say that if you're going to make some sort of weird mix-up, this is probably where you're going to do it. What if I have one more example that looks like this? And it may be phrased differently than this. Usually I tend to put the keyword in there, although I noticed that I left it out on this. That problem kind of looks a lot like what we've been doing already, right? But it's not. What's the difference? Yeah, and why do you say I should use M1V1?
I just know whenever you're adding volume to volume, that's a trigger for me. So
Yeah. So notice, and maybe I should even rephrase, well, this should be HCl solution to make my point. Notice that here I'm talking about HCl, and here I'm talking about HCl. So there's no mole-to-mole ratio, right? There's no chemical reaction going on. So in this case, Cody's right. We should recognize that we want to use M1V1 equals M2V2, meaning that we want to take our 25.0 milliliters times our 5.0 molar, and that's going to give us our second volume times 0.25 molar. Solve for V2, which since I'm making this up, I'll plug it in the calculator. 25 times 5 divided by 0.25 gives me 500, which means I need to add 475.0 milliliters, right? Meaning, be careful how the question is phrased. This 500 is the final volume, but I only am adding 475 because I already have 25 to start with. Oops, 25. So just be aware kind of in the back of your brain that on this test, and certainly on the final, you know, you can have questions that'll be titrations, although you should notice that the word neutralize or titrate or various other kind of keywords are in there, and that, you know, you'll also have mixed in there potentially a question on M1V1 equals M2V2.
So problems like this, you see things not matter because
Oh, should I keep track of them, I guess?
what would
3, 2, 2. I should have written 480 milliliters. Whoops. Sig figs, dummy. Oh, I guess 25. I would normally rephrase the question better and probably make sure that I went like this. Here. There, Jay can cheat. So then it should be 475, right? Ah, erased, dang you. There. Normally on a test I'm better than that. However, if you notice on the test that something like that comes up and it's a little confusing, you're always free to come up and say, hey Jay, you screwed up on the sig figs. What do you want me to do? But since, yeah, that's the bad part about making problems up off the top of your head. What I should do is just make sure that every example I do is always like 3 or 4 sig figs and be done with it. And I never have to think very hard. But in real life, it's always random, so.
So it's 475 milliliters of water?
Yep, that we would have to add to get our total volume of 500 milliliters of water. Heck, I suppose I should go put that there, put an extra little 0 in each of those. There. So that's it. I just wanted to basically, just wanted to review this topic and not use the word basically too much. Or arguably. I'm working on it. Yes, this is 15. This is the stuff from homework 15D. So that's it for me. What I'm going to suggest is that we either have people just randomly ask questions after I kind of save the file, and then, you know, if people want to, turn in all the homework you kind of want graded before the test, because if you turn it in on Wednesday, I'll probably have time to grade it, but I might not. Let's see, I told people I would be back here at 7 o'clock tonight, because I'm going to go play racquetball from 4 to 6, and then I want to eat. I moan about my computer locking up for 5 minutes at the end of this video. Just die. Die, 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 PowerPoint.
Did it just crash?
PowerPoint did, but the video thing is still lagging out. I have extras probably laying around in my office someplace. Oh my gosh, server busy.